Good morning. Today we are going to complete our chapter Quadratic Equations. In the previous session, we have talked about how to solve a quadratic equation E by using the discriminant delta. In this session, we are going to talk about how to solve a quadratic equation using the reduced discriminant, which is denoted by delta prime. This method, we can only use it if b, which is the coefficient of x, is even. All of you know that an even number can be written as a multiple of 2. So if b is even, then b is equal to 2b prime, where b prime is an integer. Then we can solve the quadratic equation using delta prime, such that delta prime is equal to b prime square minus ac. The difference between delta prime and delta, here we have b prime square, not b square. And we don't have minus 4ac, here only minus ac. So delta prime equal b prime square minus ac. Of course, since b is equal to 2b prime, then b prime is equal to b over 2. And we have three cases. If delta prime is negative, then the equation has no roots. If it's 0, then it has one double root, which is x prime equal x double prime equal minus b prime over a, not 2a over a. Pay attention. And in the last case, if delta prime is positive, then the quadratic equation has two distinct real roots, which are x prime equal minus b prime plus radical delta prime over a. Pay attention, the difference between this case and the delta and the case in case of delta. And x double prime equal minus b prime minus radical delta prime over a. Let us take an example. Solve the following equations. In equation number 1, 3x squared minus 2x minus 5 equal to 0. As you notice here, b, which is minus 2, is even. Okay, so we can solve it using delta or delta prime. But here I prefer to solve it using delta prime because the numbers will be smaller and easier by calculation. So here, in this equation, a, which is the coefficient of x squared, is equal to minus 3. B is minus 2, so it's even. Then we can find b prime, which is b over 2, so it's minus 2 over 2, so it's equal to minus 1. And c is equal to minus 5. So we calculate delta prime. Delta prime, which is equal to b prime square minus ac. So the answer will be, pay attention here, b prime is minus 1, so minus 1 all square minus into minus 3 into minus 5. So the answer will be 1 minus 15, which is equal to minus 14. As you see here, the answer of delta is minus 14, which is a negative number. Then the equation has no real roots. Equation number 2. 2x squared plus 4x plus 2 equal to 0. In this equation, a is equal to 2, b is equal to 4, which is an even number, then b prime equal b over 2 equal 4 over 2 equal 2, and c is equal to 2. Here we can use delta prime, and it's much easier since b is even. So delta prime equal b prime square minus ac, so the answer will be 0. Then the equation has one double real root, which is x prime equal x double prime equal minus b prime over a. So it's equal to minus 2 over 2, so it's equal to minus 1. Equation number 3. 3x squared plus 4x minus 5 equal to 0. Here a is equal to 3, b is equal to 4, which is an even number, then b prime equal b over 2 equal 2, and c equal minus 5. Delta prime, which is equal to b prime square minus ac, it's equal to 19, which is positive. Then the equation has two distinct real roots, which are x prime equal minus b prime plus radical delta prime over a, which is minus 2 plus radical 19 over 3, and x double prime equal minus b prime minus radical delta prime over a, which is equal to minus 2 minus radical 19 over 3. Here we have a small note. In this note, we have if E, which is the quadratic equation having the form ax squared plus bx plus c equal to 0, such that, of course, a different from 0, has roots, one double root or two distinct roots, then the factorized form of E is a, which is the coefficient of x squared, into x minus x prime into x minus x double prime. So this is the factorized form of E. Let us take an example. In this example, we have an equation which is 2x squared plus 4x plus 2 equal to 0. This equation, we can solve it on delta, either delta or delta prime. So we will get the answer that this equation has one double root, which is minus 1. Then this equation can be written in the factorized form, which is, or we can factorize this equation by writing it in the form. The first, a is 2. So a, which is 2, into x minus x prime into x minus x double prime, which are equal. So the equation will be 2 into x plus 1 all square equal to 0. And this, we call it the factorized form of E. In part 2, the equation is 3x squared minus 4x plus 1 equal to 0. So we can factorize the equation by finding first its roots. Its roots are here 1 over 3 and 1. So the factorized form of this equation will be a, which is 3 into x minus 1 over 3 into x minus 1 equal to 0. As a conclusion, or as a summary for these two sessions, in order to solve a quadratic equation, first, if b is any number, even or not, we can use always delta, which is the discriminant, which is equal to b squared minus 4ac. Then we see its sign. If it's positive, then it has two roots. Negative, it has no roots. 0, so it has one double root. But a special case, if b is even, then we can use the reduced discriminant, which is delta prime. Delta prime is equal to b prime squared minus ac. Okay, and as a last note, we can factorize the quadratic equation E after, or we can write the factorized form of any quadratic equation E, of course, if it has roots. After finding these roots, okay, the factorized form will be written in the form a into x minus x prime into x minus x double prime. Till here, we reach the end of our session for today. Thank you for listening. Have a nice day.